composite materials, normally when you want to build something, that product is called a structure. The product is a structure. Okay? And then the material we use is composite materials. A composite material can be just like a sheet of paper. Okay? And then you use that paper to construct into a structure. Okay, and basically composites are materials that consist of two or more constituents. Okay? And what we are interested in is the properties of the combinations of the materials. Okay, we are taking the best of each of the material, best of each properties or each characteristic of each of the materials.
Oh my gosh, it's so cute.
And there are many composites around us. It's not new. It's not new. But for aerospace, they are very narrow. The composite material they use are very narrow. Okay, but for general composites, it's everywhere. A piece of plywood is a composite material. The bones inside our body is a natural composite. Okay, the tires they use for the automobile is a composite material. In fact, it's a very complex composite material. Okay, everywhere is composite material. So for aerospace, if you are just looking at aerospace, the usage of composite materials has increased a great deal. Okay, starting from 1975, only very little composite material were used.
Hey babe, we should walk through the bay a bit.
Only very little composite were used in the 70s. Okay, progressively until now. Okay, the 787, the Dreamliner, okay, has 15% composite materials.
What's the Boeing 787 in the chart?
Hey, wait. SOS.
Okay, 50%. So you can expect what happened to you if you were to take the plane and then it bursts into fire. Okay? Or if there is a crash. Okay? If you crash with the old plane, more likely those passengers in the old plane has a higher chance to survive than take the high-tech one. Okay? Because a lot of composite materials.
Composites are more fragile.
Fragile, yes. When you see the Formula One car crashes, it just disintegrates into pieces. And then if there is a fire, it turns into ash.
Carbon fiber alone are composite.
No. The definition is two or more materials
Carbon
put
fiber is
together.
Apple cars use carbon fiber.
Yes, the reinforcement is carbon fiber, but they need glue to put them together.
Yeah.
Then it becomes carbon fiber plus the glue, the epoxy, it becomes composite material. And they are using this type of materials on the plane. Okay? So, yeah, your notes has no color.
Say that, what the hell?
Okay? But if you want to look at the color, you must go into the blackboard. Okay. CFRP.
A bit.
Carbon fiber reinforced plastic. Is CFRP. So let's look for them. Okay, quite a lot.
I know how many seats inside. 583.
Okay, in blue. Okay,
Including the
carbon
pilot.
Including pilot.
fiber reinforced plastic, and then we have GFRP.
I think 3 is for the pilot.
Plus minus 5.
Plastic, glass fiber one, less. Because the reason is it's less strong, okay, compared to carbon, and is heavier than carbon
Look at the
fiber.
tip, it's random.
Yes. Fiberglass is heavier than carbon
It's
fiber.
is random.
Okay.
So random.
And then there are some areas it may be hybrid. Hybrid means that one layer fiberglass, one layer carbon fiber, then one layer they just add on like your plywood. Okay. several layers. Okay, alternating. Okay.
Winnie the Pooh. He wants to give Winnie
Here,
the
here,
Pooh
don't
facial.
have, but they may be used. And then this chart shows a glass, a very special one you saw in the video last week. Aluminium plus glass fiber. Aluminium, glass fiber, aluminium, glass fiber, aluminium, glass fiber. They use it in the A380. Okay. They may not use it on the 787. Okay.
You must move the snout.
So, what goes into the 787? Okay. Others, that means any other material that is not there. None of this. Okay. We have steel for landing gear, basically, quite heavy. Then we have titanium, 15%. Okay, but in the past, you may thought that the plane is made of titanium material. Okay, because you know that titanium is light, but normally they will not use titanium unless necessary because it's very costly. Okay, and then aluminium we use quite a lot. And then for advanced composite, now 50%. Okay, we go to
Difference between carbon laminate and carbon sandwich.
okay. I mean, not the so direct one. That means the difference. That means it could be a sandwich, or could be a hybrid, or something like that. Okay. Not so straightforward like carbon fiber.
Oh my god.
Or glass fiber. It could be with something else.
There's a term for that.
Okay, if you look at the engine, the plane
What do you
engine,
do?
the plane engine looks very big. No? The diameter can be up to 6 over meters. 6 over meters for the engine. Okay? And it looks very heavy, but it's not. Okay. If you look carefully, all the parts here are non-metal. Electronic control unit casing, epoxy, carbon pre-preps. Okay, class. For those who have tutorial today or the day before, I mentioned the word pre-preps today, right? Okay, so you can see the pre-preps. Okay, acoustic lining panels, carbon or glass pre-preps, high temperature adhesive, aluminium honeycomb. The metal now is aluminium honeycomb.
The face also.
If it's not that heavy, then how much would it take to lift it?
Very funny.
Depends on the truss.
No, I mean, how much would what kind of machine would it take to lift it to the plane?
This one, it looks big, but not as heavy as you can imagine. Okay. Fan blade, you know the fan blade, the first one, when you look at the engine, the biggest blade that you can see, the one that is drawing in air only. Okay, it can also be epoxy, carbon pre-prep, or done by resin transfer molding construction. See, if you look down the list, they are all non-metal. So it's quite light. But of course, the inside there, where the combustion is, okay, and it's high temperature, then they have to use the special alloy steel. Okay, they are so-called the exotic materials, the internal or the high nickel based alloy. Okay, where you can withstand high temperature. Okay. So for plastic parts, we treat it like metal part as well. We have to look at what properties we require, then we find a suitable material for it. Okay? Sometimes we want it to be high modular, that means resistant, very stiff. We want it to be very stiff. Okay? Sometimes we want a high tensile strength.
So you gave it
A bit look alike.
Most of the time we want a low density. Because lightweight. Most of the time they use composite material is because of the lightweight. Okay, the main reason for them to use composite material is they want it light. Okay, And then choose some materials
Does
for
it
high
like he's breathing?
conductivity, but you don't choose composite for high electrical conductivity. Basically, they are plastic.
Breathing, look.
Okay. Okay. So what are the advantages? Okay, I must apologize to D2. D2.
D1.
It's okay.
D2 will have tutorial on Thursday. So they have not seen the composite material, whereas the other two groups have seen it.
Deformed already.
Okay.
Deformed now.
And they have
You
played
see
with
what
it
they
with some
Because he said this is
brick
diamond.
by the carbon fiber.
See this diamond. So,
Okay.
you know what I did? Ask him
So basically,
closer, then I put him
They are very light in weight as compared to steel. Even compared to other material as well, it still feel very light. Okay, strength and stiffness can be tailor-made.
Do that again.
That means to meet the
This
load.
guy say octo.
That means if you know the load is from this direction, you can
Hipsters here.
put your
The
rebar
logo is
or
pink hashtag.
to face the load. Okay.
They copy.
Higher performance for
It's
given
diamond, it's diamond.
weight leads to fuel savings, excellent strength to weight and stiffness to weight ratio.
We change.
Okay, a greater variety of mechanical properties.
I think that one is a circle.
It's a parallelogram.
Yeah, I think it's a parallel.
Okay, laminate patterns and ply build up. Ply means plywood. You know plywood? Plywood is made up of plies, layers. Okay, plywood either 5 plies or 7 plies or 9 plies. These are 9 layers or 7 layers or 5 layers or 3 layers.
How many layers?
Ply build up. That means we stack it up one after another. Ply. Okay. Laminate patterns.
Suicide.
That means something like plywood. Okay, build up in the part that can be tailored to give required mechanical properties in various directions. So how do we do it? Simply alternate the ply direction. Okay, I will show it to you in a diagram afterwards. Then part counts reduced. That means you are building big parts. Okay, probably if you compare to metal ones, the part count will be lesser.
Fat some more. Not bad.
And machining will be reduced. Basically composite material, which is plastic, is resistant to corrosion and fatigue damage.
No tiger.
Okay, fatigue is breakdown after long use from vibration. Okay, excellent resistant to chemical attack and outdoor weathering, because the plane is built to work outdoor, isn't it? Is there a plane that is built to indoor? I mean, at least for the model toy plane, yes, they built for indoors. But for commercial planes, they're all built to fly outside.
Yeah. Betul.
Okay, it means outdoor, important. Because subjected to temperature change, subjected to humidity, and so on.
I got very
Low thermal expansion properties suitable for outer space application and stealth application. That means it can evade radar. Okay. And then the disadvantages. You seldom see a material where the disadvantages is more than advantages.
Digest and no digest.
Just composite material. Long list of disadvantages. Okay. Okay, materials and coolings are expensive. Okay. Sometimes you agree, sometimes you don't. Okay. After when we see what tools we are using, sometimes you agree, sometimes you don't. Corrosion problem can resist. It's not, I said no corrosion. See? Resistant to corrosion. Then now here it says corrosion is a problem.
Let that sink in.
If you use carbon fiber, okay, and then if you couple it with a metal, that means if you have a metal that contacts the carbon fiber, then over long use, under some weather conditions, it may cause corrosion to take place for the metal.
Don't touch my back.
Okay. Okay, degradation of structural properties under temperature. extremes and wet conditions, poor energy absorption and impact damage. If you have a crash, you will shatter.
Anti-cancer.
May require lightning strike protection. Okay, is there a lightning strike protection in the plane?
What?
Yes, to conduct away the lightning.
Yeah.
Yeah, there are. Yeah, several. Okay.
If not,
Expensive and complicated inspection methods. Reliable detection of substandard bonds
bodoh pun.
is difficult. Because when you glue it, and you want to see how good the joint is, how do you check?
Break it.
You break it. You break it, that means you never produce the part. So they have to use NDT, non-destructive testing. And then sometimes the tool they use is very simple for a tiny little hammer. A tiny little hammer, then they tap on the surface. From there, they can detect whether the part is properly bonded. Okay, they need experience. Same as when you go to the doctor knock your stomach, you know, a lot of weight inside there.
Really? They know people's stomach.
Okay, and defects, you know that there are defects. Okay, defects, you know they are there,
Your elephant.
but the precise location cannot be determined. And worse still, when you make a repair, the repair makes the job even worse. Okay, it can happen for composite materials. Okay, and you have to clean it properly. Okay, before you can use any glue.
Nice only.
Then you need very skillful people to work on composite materials. But when I show you the video on composite materials, if it's not in aerospace, it's not so strict. Okay? Yeah, so, but in aerospace it's very strict when they handle these composite materials. The resin, okay, the resin must be approved by either Boeing or Airbus. It must be approved. Okay? Fiber also. And then from a fiber which is maybe looks like a cloth and the glue, you can make it into products. Okay? You make it into products. Like this I-beam structure or whatever structure. So how strong is your composite structure? How strong?
Very nice.
Or I ask, how strong is the pillar? The pillar that supports the building. How strong? It depends on the properties of the structure and the material you use. Okay? One of them is the properties of the reinforced fiber. If you are using the bar, for example, to put inside the pillar, what diameter are you using and how many rods do you put inside? Okay, it's important to determine the strength of the properties. What type of cement you use, what type of glue that you use, the matrix is your glue. What type you use, what grade, same as you use the cement, what type of cement you use, what is the ratio of cement to sand to the granites. Okay, it's important. And the ratio, see, the ratio of the fiber to the resin in the composite. How many percent fiber and how many percent the resin. And then the geometry and orientation of the fiber. Which way you put the fiber plays a part. Okay? Which way you orientate the fiber, that means you lay it this way or sideway, it plays a part in aerospace. Okay. Okay, imagine your fiber is made up of all these lines. Okay? So in this way, it's called certain angle. For example, I call this 0 degrees. For example, 5. Okay, the next one you see, what angle? If this is 0, next one is 45, isn't it? Then after that comes the other one?
90, right?
90. And so on, you see? Okay, in this way, you can make the part very strong in all directions. If you want it in only one direction, then you put all long one to face that direction. Okay? But if you have too many layers, let's say 20 layers or 10 layers, it becomes thicker, but it also becomes heavier. But sometimes, and it becomes very, very strong. But sometimes we don't need that strong, but we need it to be thicker. Okay? In this case, we will put a honeycomb in between, which gives you the thickness, not the weight, and then a layer of this,
Who's this mother?
or 2 layers of this on top and at the bottom. Can you get it?
Mama's boy.
Okay, please make sure that you can see the spelling.
Where?
What is this in your notes? Can you see?
It's a
Laminate.
good name.
This one, adhesive, that means double sided, something like that. Then this one, honeycomb,
I like the meaning.
then adhesive, and then laminate. Okay, this will make sense. And this honeycomb can be of different thicknesses. Can be a thin one, can be a thick one. Okay. Then we are using this fiber. So the filaments can be non-continuous or continuous. So let's take a look at the picture first. Okay. So roving ion, continuous, tape, continuous, fabric, continuous, chalk or particulate. Is it continuous?
No.
No, it's chalk. Then how about matte? Is matte continuous?
I think no, by the looks of it.
A matte is, you see, roll up, no?
Yeah.
Like a toilet paper is roll up, but it's not regarded as continuous. The reason is they don't know the fiber direction. All this you can see the direction.
Yeah.
I know. This one is also random. That means this one basically is made up of this one put together. So it's classified as non-continuous. You see? Non-continuous, but this one, chalk and matte. The reason is you cannot see the orientation. Sorry, not the orientation, the architecture of the material. The architecture. Okay. So fiber can be of 3 types for aerospace. We have the aramid, that means the Kevlar. This one, the strongest one, which they use for the bulletproof vest. Okay. It doesn't mean that one strand can take the bullet, no. It need to have other things as well. Okay. Then we have carbon fiber, then the glass fiber.
Zalora is my scanner.
So what is the typical characteristic of a sandwich material? Sandwich. That means we have a honeycomb in the middle. The sandwich material.
ZDA.
For those who had held it before, the floorboard that I passed around the last 2 days, was it very light? Yes, everybody agrees that it's very light and high flexural rigidity. When you try to twist it, it resists your twisting, isn't it? Okay. And then excellent in thermal insulation. Okay, it can take heat. Okay, it can withstand heat. Not strong fire, heat. Okay. Yes. After the class, you think some I spend a lot of money. Okay, but the caution is, and when we knock on it, what happened? The sound just went through, right? Okay. No acoustic insulation. Okay, because it's hollow inside, in the middle is hollow. Okay, fire resistance is no good for certain core. If you use the paper one, not so good. Okay, the aramid paper, the one that I shown to you, not so good to withstand fire. Risk of buckling is greater for classical structure. This is the most difficult to understand statement. What does it mean by a classical structure? classical one.
Yeah,
Composite. Basic. Very easy.
yeah, lor. Still can
Okay,
ask.
normally when we make
Bro, not rocket.
a wall or something to or a support, okay,
What
and then
have
we
that?
want to support something, we have support wall or something like that. Okay, if you were to use the composite that you produce for support for the classical structure, okay, if you have a load this way, the board that I pass around,
She wants to be
it
more well.
can withstand the load horizontally, but this way, if you exert the load, it may buckle. You know buckle? Something like crumple. Buckle.
Emoji so big.
For long bars, if you press on both ends, it may bend and buckle, break, bend and break. Okay, so it's no good for. You cannot use the sandwich material to be a support for the load. You know.
I randomly post it. Holy crap, I don't even know to use it.
Okay. So the honeycomb can be metal or non-metal. Okay, metal one, it can be aluminium,
You're going to
it can be titanium, it can be stainless steel or whatever material. Metal one. Then it can be also paper ones. Paper is ceramic paper. They call it Nomex. And then all these are no good for sound insulation. If you have noise, you will just go through. Okay. If you want to have some insulation effect, you may use foam. Like those are that you contain the food, the one, the white color one. You may use that foam. If you put the foam in between two laminates, it may absorb some noise or sound. Then there are some special wood used also.
Balsa wood.
Balsa wood feels like a bit like gold.
Actually, I've not seen one.
What's that?
I worked with it back in secondary school.
Balsa wood, like foam.
Yes, foam. It's also you can leave your fingernail mark in it.
It's soft wood, like foam wood. Okay, but it's wood, it's not plastic. Okay, you use it in the eye.
I didn't know it was actual wood at first.
It's, I think wood dust made into this. Okay, Balsa wood. Okay, if I were to ask you to memorize the names of the parts of the aeroplane, I think it would be a big headache. Okay? Ailerons.
What are the ailerons?
Or some on the wings.
The winglets.
On the wings. But on the wings, there are many parts on the wings. What's the ailerons? What's the elevator? Then we have the flaps. Then we have the leading edge. We have the trailing edge. They are all on the wings. The wings have many parts. Okay? Then we have struts, nacelles, spoilers, radomes, okay, flooring. Okay, you only know, I think, a few. You know what is a flooring? Of course, the one that you walk on.
The deck.
The floor. This floor is the flooring. Then you may know what is the spoilers. If you like cars, you may know what is the spoilers.
Yeah. Spoilers are the aerofoils.
Aerofoils. Okay, and then I think you should know what are doors. Okay. What else do you know? Radome. What is a radome?
The nose.
It's simply the nose of the plane. Okay, it's a cover. Actually, the nose is a decorative cover.
Or just a decor.
It's a decorative
So
cover.
how come the actual nose is flat?
No one. I mean, at the end of the plane, actually, it's flat one. Okay, so they put a nose cover there.
But why would it be?
Of course, because of the radar and so on that they put there. Yeah, a lot of detectors in the front. Okay, then to protect all these detectors, they put a cone there. They call it a radome.
Say lah.
Say lah, cik. Aesthetics.
Okay, then, you can also use for outer space. You can helicopters, space shuttles,
Bochu.
satellite, and so on.
Satellite.
Okay.
Satellite bojo.
Okay, I'm going to show you a highly technical video on composite manufacturing. Everything about composite.
Now 1:30 already.
What you will see is not 100% aerospace. little bit aerospace. Composite can be used anywhere. Can be for ships, can be for bicycle, can be for golf club or whatever thing. Okay? They are not all aerospace one. Little bit aerospace only. Okay?
Is that in the box?
Because he accurate saying 5.5 in like 5.5, I don't know how you do it. So I say you put accurate, I think it's really accurate because I'm cute already. What? You
5.5.
I cannot answer. And then the answer.
is it?
5.5.
5.5.
Oh my god, I'm recording the video.
Oh, nice. Video within a video. Videoception. Oh, orange juice.
Cheer louder. Dolby 7.1. Cheer louder.
First rep. D1, 2, and 3.
Composite manufacturing series, examining the materials,
Yeah, this is
tools, and techniques used for composites fabrication.
Not bad.
This program is an introduction to composite
No lah,
materials.
1020p. Very high def.
Composites are materials combining at least two distinct materials, which together provide superior performance and/or lower manufacturing costs.
Cost lah.
Fiber reinforced composites consist of a
I think like
reinforcement
one day
material
1 pixel.
and a matrix, or base material. The reinforcement's function is to improve the mechanical properties of the composite and is typically the main load-bearing element.
Echo is
The
coiling.
matrix functions as a binder for the reinforcement and controls the physical shape and dimensions of the part. The primary purpose of the matrix is to transfer the load or stress applied to the composite to the reinforcement. The matrix also protects the reinforcement from adverse environmental effects. Of the several types of composites, fiber-reinforced composites are the most widely used for structural and non-structural applications. The most common and widely used fiber-reinforced composites are fiber-reinforced resins or polymers, which are commonly referred to as polymer matrix composites, or PMCs, or even simply as reinforced plastics. These composites are typically lightweight, strong and rigid, provide high strength to weight ratios or specific strength, and high rigidity to weight ratios or specific stiffness. Another major advantage is that fiber direction can be oriented to suit the applied load direction. Applications for polymer matrix composites include automotive and performance racing parts, boat hulls, aircraft components, and many more. Besides being available separately and combined in fabrication, reinforcement fibers and matrix are also available together in what is called pre-preg, or pre-impregnated material. Pre-preg combines partially cured resin with fibers and must be kept refrigerated prior to use to inhibit further curing. Use of pre-preg simplifies and speeds composite layup and ensures higher quality parts. Fiber and matrix quantities are more accurately maintained, providing more consistent mechanical properties. Both continuous and short fiber forms of pre-preg are available. An important structural aspect of polymer matrix composites are the tensile properties, since they are indicators of how a material behaves under loading while in tension. Three of the most important tensile properties for polymer matrix composites are tensile yield strength, tensile modulus, and ultimate tensile strength. Tensile yield strength is the tensile stress required to permanently elongate a material loaded in tension. Tensile modulus is the ratio of tensile stress to tensile strain for stresses below the material's elastic limit. Tensile modulus indicates the material's stiffness or rigidity. Ultimate tensile strength is the maximum stress a material can withstand before rupturing. The principal types of reinforcement fibers used for plastic matrix composites are glass, carbon or graphite, and aramid. The two primary types of glass fibers available for composites manufacturing are E-glass and S-glass. E-glass is an abbreviation for electrical glass borosilicate glass fibers. These fibers have high electrical resistivity, are inexpensive, and are the most prominently used in polymer matrix composites. S-glass, which is an abbreviation for structural glass, is a magnesia alumina silicate glass reinforcement fiber designed to provide very high tensile strength for composites. The S-glass is about 30% stronger and 20% more rigid than the E-glass, and is slightly lighter in weight. But S-glass is far more costly than E-glass. All the glass fibers are heat resistant, retaining about half of their strength at temperatures up to 700 degrees Fahrenheit or 370 degrees centigrade. They are moisture resistant and corrosion resistant as well, except to strong alkalis and hypofluoric acid. Glass fibers are produced in various commercial forms, including rovings, which are a group of parallel strands gathered in ribbon form and wound onto a cylindrical tube. Other commercial glass fiber forms include chopped strands, yarns, and woven or non-woven fabrics. There are two principal carbon or graphite fibers used for plastic matrix composites. Pan carbon, which is the more common and much more costly, and pitch carbon. Both pan and pitch carbon fibers are lighter in weight than glass fibers, but heavier than the aramid fibers. Their density ranges from 61 thousandths to 76 thousandths pounds per cubic inch, or 1.7 to 2.1 grams per cubic centimeter. The heavier the carbon fiber, the greater its tensile modulus, ranging up to 75 million pounds per square inch, or 517,000 megapascals. Tensile strength ranges from 220,000 to 820,000 pounds per square inch, or 1,520 to 5,650 megapascals. The carbon fibers are extremely brittle, having a strain to failure of only 0.3 to 1.8%. They are, however, quite heat resistant, having maximum surface temperatures as high as 1,000 degrees Fahrenheit, or 540 degrees centigrade. The aramid fiber is much lighter than the glass. Its tensile strength can match that of the glass, and its tensile modulus can be much greater. Its strain to failure is 1.9 to 4.4%, and its coefficient of thermal expansion lengthwise is negative, which permits making composites of zero or near zero thermal expansion. Aramid fiber has limited heat resistance, and its compressive strength is low. Resistance to ionizing radiation and chemicals other than high concentrations of strong acids and bases are excellent. However, prolonged exposure to light and ultraviolet adversely affect mechanical properties. Two important parameters governing overall properties of reinforcement materials for plastic matrix composites are fiber orientation angle and fiber architecture. Fiber orientation angle is the angle of the fibers relative to the loading direction. For example, 0 degree along or parallel to loading, 90 degrees transverse to loading, and plus or minus 45 degrees for such angular placement relative to the loading direction. Fiber architecture pertains to fiber arrangement, which can be linear, or two-dimensional, or three-dimensional. In linear form, the fibers can be continuous or discontinuous. With continuous fibers, orientation can be precisely controlled. With discontinuous fibers, little, if any, orientation control is possible.
Isn't it like the
Two
E-glass?
and three-dimensional arrangements contain continuous fibers that are interlaced, intertwined, and interloped. These materials provide good control of fiber placement and orientation and can be used to produce complex shapes. The matrix materials for fiber-reinforced plastic matrix composites can be thermoset resins or thermoplastic resins, with the thermosets being the most widely used.
Is that like plastic?
Thermoset resins require curing to develop their desired mechanical properties. Curing may be at room temperature or with an open-air heat assist. Curing is also achieved using heat platen presses, dies, ovens, or autoclaves. Once cured or set, thermosets cannot be reprocessed. Curing cycles for composites can be long, ranging from an hour to half a day or more. The process is typically faster in presses or dies than in ovens or autoclaves. But ovens and autoclaves can accommodate much larger parts or many small ones. Thermoset polymers are generally more thermally stable and chemically resistant, less costly, and with a few exceptions, more heat resistant than the thermoplastics.
Looks fun.
Some of the primary thermoset matrix materials are epoxy, polyester, vinyl esters, phenolic, cyanate esters, bismuth-imide, and polyimide. Of these matrix materials, the epoxies have found the greatest use in high-performance applications, including marine, aircraft, and aerospace applications. Their principal advantages are processing ease, good mechanical properties, and low cost. Thermoplastics are less brittle than the thermosets, having a greater strain to failure or crack resistance, and higher impact strength or toughness. They also have unlimited storage life, are processed more quickly, can be softened repeatedly, and unlike thermosets, thermoplastics can be recycled for reuse. Discontinuous fibers are more commonly used than continuous ones with thermoplastics, and injection molding is widely used for product manufacturing. The parts made of thermoplastics, however, are typically much smaller than those made of thermosets. Among the most common fiber-reinforced thermoplastics are the acetyls, polypropylene, nylon, polyethylene terephthalate, polybutylene terephthalate, and polycarbonate.
I can only say nylon.
Let's review the material contained in this program. Fiber-reinforced composites consist of a reinforcement material and a matrix or base material. The reinforcement's function is to improve the mechanical properties of the composite and is typically the main load-bearing element. The matrix functions as a binder for the reinforcement and controls the physical shape and dimensions of the part. The primary purpose of the matrix is to transfer the load or stress applied to the composite to the reinforcement.
Oh yeah.
The matrix also protects the reinforcement from adverse environmental effects. The most common and widely used fiber-reinforced composites are fiber-reinforced resins or polymers, which are commonly referred to as polymer matrix composites or PMCs, and even simply as reinforced plastics. Besides being available separately and combined in fabrication, reinforcement fibers and matrix are also available together in what is called pre-preg, or pre-impregnated material. The principal types of reinforcement fibers used for plastic matrix composites are glass, carbon or graphite,
You must think carefully now.
and aramid. The matrix materials for fiber-reinforced plastic matrix composites can be thermoset resins or thermoplastic resins, with the thermosets being the most widely used.
Just faster.
Thermoset polymers are more thermally stable and chemically resistant, less costly, and with a few exceptions, more heat resistant. Some of the primary thermoset matrix materials are epoxy, polyester,
I'm gonna get
vinyl esters,
I'm gonna get that.
phenolic, cyanide esters, bismuth imide, and polyimide. Thermoset resins require curing to develop their desired mechanical properties. Once cured or set, thermosets cannot be reprocessed. Thermoplastics are less brittle than the thermosets, having a greater strain to failure or crack resistance, and higher impact strain or toughness. They also have unlimited storage life, are processed more quickly, can be softened repeatedly, and unlike thermosets, thermoplastics can be recycled for reuse.
It's tiring and you don't see like very
Among the most common fiber-reinforced thermoplastics are the acetals, polypropylene, nylon, polyethylene terephthalate, polybutylene terephthalate, and polycarbonate.
because you only want your kid.
Say got more?
For 1 more hour.
But I don't think it's funny.
Oh, he got lots.
I'm just like this.
You never know, it's just named like that.
A layer of catalyzed resin
What jokes can I make?
No, please don't come up with any rubbish jokes.
Let me think.
No, you're not about
Not so many times.
You went another bunch. Is it?
Don't read.
Another chocolate.
Does it look high tech and all for the composite manufacturing?
Faster.
It doesn't look high tech.
You can do it on your own. Why not? If you want to do it, we simply buy some fabric and then we buy the
Glue.
glue and then that's it finished. We can start to produce our own fiberglass, both and so on.
So high tech.
Teacher take this very easy.
And actually the video is quite bad. It shows that you need to observe safety rules. Okay. See the old ladies, I think maybe she had died already. Okay. And you know when they do sawing of the cloth, the
You don't wear mask.
didn't wear, no. Then the fine particles are flying all over the place. Okay. And then you're in here, finish.
ISO.
What when they're spraying the
Certified.
fiberglass?
That one at least bigger. That one. They spray. That one is bigger. But when they are sawing and they are cutting, that one become very fine, small particles. The big one not so bad. You won't use the big piece inside. The tiny little ones, the worst. Okay. When I went for training, I was made to put on the N95 mask for the whole day. Okay.
How you say?
Yeah.
Hey dude,
Do you have this
Here
in
it
your
is.
notes? The first page.
what the hell?
is a flow layout of a typical metalworking industry. Okay, those processes we know already. Okay, we have raw materials, and then they check the raw materials for faults, and they supply it to us in terms of sheets of plates, can be castings, can be forgings. In fact, we've done all this, right? Casting, forging, we've done sheet metalworking. Then from there, we may do some cutting, forming, machining, grinding, polishing, and so on. Then we put it, we assemble it, and we make it into a product. Okay, for composite manufacturing, same thing. You can get from the supplier fabric, fiber, and resin, and then you fabricate your own parts. Okay, but like the old lady was doing. Okay, you put the fiber there, you pour the glue, and then you manufacture the own parts. Or you can buy the ready-made one. The ready-made fiberglass is pre-prep. Pre-prep. That means like what the man did for knives, you peel off one layer and then you stick it on somewhere. That is a pre-prep, much neater and much nicer. In fact, it's nicer, neater, and better strength. Okay, because it's made in the factory, not by you. Okay, then we go for layup. Layup means you put on layer by layer, same as you use your erasing tape. Erasing tape, when you make a mistake, you put one layer, not good enough, you put another layer, it means you are laying up layer by layer. Lay up. Okay? And then after that, we may send for some testing if you want to. And then we may do assembly, trimming, fastening, and so on to finish the part. Quite similar to the metal working. We still need to do assembly, like fastening, building, and so on. Okay. So now we look at how to produce the processes of making composite structures. Okay. Processing methods for thermoset system. Okay. Cutting and kitting. Okay, basically, to cut the fiber, is it very difficult? To cut the cloth that I passed to you in the class,
I also want.
it looks like it's not difficult, but it is. Okay, if you use a normal pair of scissors to cut the fabric, the fiberglass fabric or the carbon fiber fabric, because it's so hard that when the scissors try to shear it, just imagine that the cloth, the fiber are all round rocks. The shearing action will actually push the rod away, and then you will distort the architecture. Okay, it's no more straight. It's at the end there all curving. Same as you go for your hair studies. You cut your hair. Okay, if the fellow uses a pair of scissors that is not so sharp, what happens? It's pushing your hair away before it cuts. Okay, and sometimes you feel the pain. Same thing. Okay, cutting. What are the processes available to us to fabricate a structure? Very commonly used, manual layup. Just now I told you the term layup already. Layer by layer. Okay, patiently you build up your product. Then automated tape lamination. That means instead of using manual layup, you're using a machine that, like your erasing tape, similar as I saw in the video. It moves on the surface and then it spreads the tape. Then we have filament winding, like the man walk around with a toilet roll like that to a rotating object. Okay, filament winding.
This is the earlier one, 58 weeks, now got 60%.
Can be a cloth. If you don't need the strength so much, you can use a cloth. Okay. Okay, then Fortrusion. We know what is extrusion in metalworking. Extrusion means we push the material from behind, the billet from behind, and then make it comes out from the end. Okay, Fortrusion is you pull put it instead
The
of
sister can.
Not bad, not bad.
Okay. Then we have resin transfer molding,
Is this you?
a molding process.
Oh, so
After
cute.
that,
Is this
casting.
you? Oh,
Okay.
what does that
From
mean?
this, we
Wait,
can
your
make
sister how
virtually,
old?
virtually
That's my
any
sister.
parts already.
Your sister how old?
From these few processes, we can
Cannot,
make
that's some
virtually every part.
Oh, I just found this over from
Then for curing,
I also saved that.
when we use glue, we leave some glue. If you leave it there for a few minutes, it will cure by itself.
Cure.
Cure means harden.
Oh,
No more. The glue become cured already, become hardened.
if you put
Okay, but if you apply heat, normally you will speed up the curing process.
cure,
Okay,
economy.
so to apply the heat, we may use oven, or you may use a blow, something like a hair dryer, a portable blower, or you may use autoclave. And autoclave was used in which casting process? Investment casting process. Okay, same thing, they use it. And this autoclave is giant one. Just imagine the whole plain body, not the whole length, the diameter of certain length go into an autoclave. It means it must be bigger than the body, about 7 meters in diameter or more. Diameter 7 or more meters for the plain body to go inside there.
Yeah.
Okay. And then debagging, a very interesting process. Debagging,
Remove the
then
bag.
finishing. Okay. Then post-process fabrication. After the part cure already, you may want to paint it, you may want to do additional work. That is post-process. That means the part is cured already, hardened already. Then you do something, drill hole and so on. Okay.
Right, Rebecca.
Painting, trimming, cutting, drilling, and so on. Then later you assemble a few pieces together to make the
Brother-in-law.
door or structure.
Can what? Brother-in-law.
Ew, this brother-in-law.
Okay, and that's now one of the disadvantages of composite material. The fellow says that it's expensive. Tooling is expensive. So you look at this tooling, is it expensive?
Sana.
No.
Cannot.
Cannot lah.
This one is
Cannot
pre,
lah.
you know. This one is before. This one is before the glue is cured. Everything is soft. The cloth, the fabric is soft. Okay, and this pair of scissors is not the ordinary one that you use every day. It's not the $2 one.
He go plastic
Okay,
surgery
a
first.
pair of scissors to cut the fiberglass can cost up to $200.
Cannot.
It's different. Yes.
Don't they also have to clean the scissors blade after each cut?
Oh yeah, yes, serious.
Because the rest will buy the blade.
Yes, that is a serious offense. Okay, this is without the glue yet. This is to cut the cloth. Okay, cut the cloth easy. The fabric, but it's fiberglass. It's quite hard. So if you what happens if I use an ordinary pair of scissors? Yes, I may still cut it, but it will damage the architecture. That means the thread will be pushed before it's cut. Okay? No good. If you use a proper pair, when you cut, the sound is very crisp. If you go to the tailor, they cut the cloth with their good scissors for the fabric one, the cloth one. The sound is very nice. You can hear the shh, very nice one. Okay, you use the $2 one, then you get entangled. No? Okay, you will not cut properly. Okay, so same thing. Good one. It holds down the fiber before it shears it. That means during the cutting action, it holds it down and then it cuts.
No, he posts long time ago.
Sorry.
49 minutes.
Then we use a lot of templates.
Doesn't look.
Okay, templates to help us. You no need to use a ruler to construct so accurately on the fabric. No need. You give some allowance, a few here and there. Okay, slightly bigger. So before we draw on the fabric, we are not allowed to draw on the fabric in the first place.
Are these all your siblings?
Okay,
Wait, I cannot see his face.
so we make a template. A template may be just a piece
No lah,
of
Zions.
newspaper that has the shape. Okay, then put on top and then you cut according to the shape. Then we often have to use pattern nesting to reduce wastage. Okay, because whatever you produce cannot last for a long one. No. Sometimes 30 minutes later you have to throw it away already. the shelf life can be as short as 30 minutes, depending on the epoxy you use. Some last, some take 2 hours to cure, some take 30 minutes. Okay? Because they have to do a quick repair job on the plane, which is flying off very soon, 1-2 hours time. So they have to have an epoxy that can cure quite fast. So if you use that kind of epoxy, it will not last. It means after a short time, after tea break, come back, gone already. The part cannot be used. You have to throw it away. Okay. So to reduce wastage of the material, we use pattern nesting. That means we lay out all the newspaper there first, and then faster we cut. Okay. So cutting tools for uncured. Uncured. That means now the fabric has glue on it already. Okay. As now you look at this picture, only the fabric without the glue yet. Then after you pour glue on it, you spread the glue. Then now, if you want to cut it, it's more difficult already. Because cloth plus the glue plus the epoxy. So when you use that one to cut, the glue will stick to the surfaces on the scissors. Okay.
How do you clean after?
Okay, very good. How do we? What is the best solvent to use? What solvent do we use? No, not kerosene, not turpentine. We use acetone, a commercial cleaning solvent, which is very good.
It's only found in nail polish remover.
That one is very diluted.
Yeah, but it's not acetone in it.
Yes.
So you use concentrated acetone.
For industrial use, that one, commercial use one is very diluted form.
But isn't acetone also corrosive if concentrated?
Tomorrow.
Not so.
So
Okay, so the manual we can use for uncured laminates. That means the cloth with the glue. We can use a pair of good scissors, shears. Okay, or you can use an antique cutter. Because do you know what's an antique cutter? Do we call this antique cutter, paper cutter? Antique, N-T. You know why they call it antique cutter? Because the first one that comes into use is the brand NT. You can buy from the bookshop. It's NT, the better grade one. Yes, that's why you call it NT cutters. Actually, it's paper cutter. Okay. Then this one is called box cutter. We call it box cutter. Then we can use a carbide wheel and a pizza cutting. When finish cutting, always remember, you see, when finish cutting, always clean the residual fibers from the blades. Acetone is recommended for dissolving and removing pre-preg resin, urethane, adhesive, epoxy, etc. It's very good for this glue base. Okay? What happens if I don't clean? If I forgot to clean the glue away from the scissors, you can't move it anymore. And then it's a different story now. You put acetone, you will not dissolve it already because the glue is cured already. So you have the hard time scraping it and so on to make it work again. Dismantle the scissors, scraping away the glue, and then clean it. Very tedious work.
Or you can still use acetone on set.
Not the effect also good. It's cured, change property already. Okay, and then we can use machine to help us. We may use a laser machine, but laser will cause some burning. Will cause burning, charring on the parts. Then we may also use water jet to cut the laminates. Okay, but messy because of the water. Okay, and then we may also use this one is cutting of uncured laminates. This one, this piece, the green one, basically is a pre-preg material. It's produced in the factory and we bought from the factory. Then the green one is simply a protective tape only. No use one. You peel it away, you throw it away. Okay? And then they use a program to program whatever shape and then have it nested here. Nested here. And whatever green one you see here, the leftover will be thrown away because it will be cured very quickly. Okay? You cannot say cut and then after that faster keep this one. Cannot. You will cure. You will cure. The glue will automatically harden. Okay?
He never put anything on.
And then this is how we cut the uncured composite material. Then what happens if I want to cut the honeycomb, the core, okay? The sandwich core, the honeycomb? How do I cut it? I may use a saw, again depending on the material. I may use a saw, I may use a very sharp knife, and then I cut it. Okay? Because it may be paper only. Depends. It can be paper, it can be metal, depending on which. I may use a band saw, I may use a grinder to cut if it's very hard. Grinder.
Nobody cares.
Then you see the saw may be diamond or carbide with blades.
Nice piece.
Okay. So after I prepare the material already, the glue is on the cloth. I'm going to put inside a mold. I have produced this mold. Okay, assuming this is a bathtub. Okay, assuming this is a bathtub. Okay, I'm going to make a bathtub by the lay-up method. Lay-up method. Okay. What should be the first thing I do? Logically, before I put the fabric or whatever glue there, the first thing I must do, common sense. Because I'm going to use glue, right now, I must make sure that after I finish the product, it can come out from the mold. Right now, no point I make a product and then it stay inside the mold there. So I must make sure I coat it with a release agent, a jar that will not let the glue stick to the mold. It's important. Okay? This picture did not show. Okay. Sorry, the release agent. Okay? To prevent the composite from sticking to the mold, a mold release or parting agent is first applied to the mold. Important. You know, you finish the part, you are very happy already, then you struggle to remove the part from the mold and the part is broken. Okay? So, this one is important. So, after you put there are a few ways of doing it, you saw in the video. One way, the first way is I put the cloth without the glue. The cloth only. Like this method, dry reinforcement fabric, means dry one. I put on the mold, after put in place, then I pour the glue there and then I spread the glue. One way. Okay? But it's only one layer, isn't it? One layer thick. Not thick enough, I put another cloth and then I spread some more. Not enough, I carry on third and fourth and fifth and sixth. Sometimes you may need up to 10 layers to get to the thickness that you require. Because one layer is about less than 1 mm, no? If you want a 6 mm, you need so many layers already. Okay? One way, right now. Another way is I put the glue on the cloth. Already, the cloth has the glue, and then I bring there and I put inside the mold. Not enough, I take another one. I put the glue somewhere outside. I put inside. It means the glue may be applied here, may be applied outside before coming to here.
I liked it.
Or another method is I don't make it at all. I don't make any glue at all. I buy the ready-made one. I buy the pre-prep. Cut to the shape, come here, paste on it. Okay? This is how we do layup.
Did you find it?
lay up method. One layer after another. That's how you saw the man held something on the hand in the video, and then he tried to put, to build the part, okay, by laying up. Okay, with this method you can make already many things, many structures or many products, but may not be so nice because basically it's manual. Okay, may not be so nice. Manual work. Okay. Is that clear? That is manual layout.
Oh.
Yeah, release firm must be there beforehand. Okay.
Wow.
In the shipbuilding industry, or as now we saw in the video, the orientation of the plies, that means layer, the orientation is not so important for the ship, for the bathtub or whatever, not so important. But for the aerospace, it's very critical. They only tolerate up to less than 5 degrees error. So if you are going to put a clock, first layer you want 0 degrees, you put. Second layer you want 45 degrees, you put. How do you ensure that it's 45 degrees? Well, you can use a protector to guide you. No, not up to 1 degree accuracy, a few degrees acceptable. Okay? But if you just ask somebody to estimate, he think that he's very accurate, isn't it? Every time I put, oh, this is 45, but it may be 30 only. So, in the factory, this is actually what is happening. Whenever you put the first ply, somebody check. Okay, the QC will check. After every ply, every ply, the QC check, okay, not approve the second ply. Okay, this QC is checking at 2 places. Okay, and then if the factory is even more modernized, they may use the laser to guide you. That means this isn't like draw a line there, but not permanent one. It just gives you the line in light, and then you can orientate the part. Okay, you guide here. Okay, this one they use in the construction industry also. Okay, it's very strict in the aerospace industry. Okay? Even the glue they have, okay, all must be approved. The scissors they use must also be approved by the Airbus or by Airbus or by Boeing. Okay, must be approved. And then the glue, even brand new one, in the store, the shelf life is very short only. The shelf life, after they reach the shelf life, it's not used, dump. Okay, unused one, dump. Okay, very strict one. Okay, what happens if this guy here certified that okay, everything is fine? Then he will make the signature. Then he will have a special personal stamper. His signature, I mean, he will stamp. I mean, he approved it, and then the plane came down. Okay, and that portion is certified by him. Then he's liable to be charged even he leaves the company within 7 years. Within 7 years, if something happened to the plane and because of his negligence, he's liable to be charged. Okay? Where even he's not with the company, he had left the company already, still liable. Okay, so no joke. That's why they are quite well paid. Any question? Okay, but if you have a part that is very big, if you have a small little bathtub, okay, you can do it manually. But if you have a part of a wing, and you saw the wing, how big the wing was in the video last week, can park how many family cars? 70 family cars on one wing.
Without spilling.
No, the wing.
Yeah, without spilling over.
Spilling over?
Part of the As the car standing close to the edge.
No, I mean just roughly. I mean just a rough guide. Okay, if you use manual layout, it's quite tough, isn't it? Okay. Have you all tried putting this protector on your handphones? The screen protector?
Yeah.
Is it easy?
No.
No, small one quite easy. But you got the 10 inches, wow, very tough already. How about the bigger ones? You put here bubble, there bubble, you know. After you take out again, worse, the dirt go inside there.
Yeah.
So same, the layout, if you do manual one, and you put, then you find that something is wrong, you tear out and all this, very difficult. So they use a machine, similar, the working mechanism, similar to your erasing tape. The erasing tape. When you use your erasing tape, you erase from left to right or right to left.
Left to right.
Mostly left to right because you are right-hander. Okay, but if you are left-hander,
No, yeah, it's right to left because I left.
your left-hander is the other way around, right? But can you go backwards? When you use your erasing tape, you go through, cannot clear. Can you go backwards? Cannot, isn't it?
Smell cancer.
Question. Can we go backward with the erasing tape? Cannot. Same thing, the machine can only go in one direction. Same thing, exactly the same working mechanism as your erasing tape. The automated tape layout.
Doing with your camera.
Okay, so you lay the
The person
tape.
who asked hopscotch replied.
She replied fish.
Okay. Use of unidirectional pre-preg tapes. Again, see the pre-preg comes out again. Pre-preg. Typical tape with 75 mm.
A good friend.
But can be as big as 300 mm. Just lay. Overhead entry to facilitate movement of the head to a large more. Simple dental contour. 30 degrees. But if you are using this machine, you cannot make something like the bathtub. Very difficult, the head cannot go in. Okay? It's for gradual rise and so on. Okay? So gradual, 30 degrees. If it's too steep, cannot. The head cannot go in. Okay, speed can be quite fast, 50 meters per minute. That machine is programmed to lay the tape, strip backing layer. Two surfaces may be heated to improve resin tag and compacting. That means this machine is built for multi-purposes and make sure that when they lay the tape, it's very strongly adhered to the surface. This is a smaller one. This is a smaller one. Okay, tape layout. Okay. Does it look like your correcting tape? Erasing tape?
She's taking selfie.
So, of course, it's very good if you can use it. Okay, it's good for large, long, flat components like wings and rotor blades.
He can become your
Owing
brother-in-law.
to the time required for manual layout, materials
become your
will be close
brother-in-law.
to out life when the task is nearly completion. Okay, if you do manual layout and you take too long, when you finish the last few pieces, they are almost cured already. Then there's a risk that it may happen, and then you may scrap the whole structure. With automated layout, it will not happen.
It's a good faggot.
It's a good.
But consistency, okay, and repeatability. Always you can get it because it's done by program. Disadvantages: expensive machines, need to program the machine, and large. You basically need quantity, large volume. But for the wings, no choice. You may not have large quantity for wings, because you may only build 1-2 planes. You may not have the volume, but big job, yes. Long production time for small parts due to head turnaround. When the head goes to one end, okay, you must turn around, go to the next end, then come back, do again. Okay? Difficulties in compound contours and complex parts, resulting in gaps and overlap. To prevent overlaps and thickness variation, small gaps are often programmed. So any question for the layout, manual and automated layout? Okay. If you have no question, then I will stop here. Okay, because the next few processes are quite difficult to.
I'll share the link on YouTube.
Sure.
Shadow winding.